Thank you very much, Professor Cunningham. It was a really engaging, really nice webinar today. I feel like I have learned a lot already. I want to start with a question, and then I'm going to check the chat box and ask the other questions that participants may have. So I have realized, so this is just the question I'm curious about. And the one of the first slides you have shared that you asked 700 children to draw what an engineer is, and then you shared their drawings with us. Mm-hmm. I have realized, so this is, I just want to ask, because you just provided like a couple of them with us, of course. Most of them draw a male engineer versus any female engineers, and you are working with underrepresented groups also. Is this something that is most of the times the case, that whenever there's an engineer in mind in kids, they are drawing a male person with a, hands-on with their cars or designs? Is it the case, or how would you?
Yeah, we definitely saw more of that in our drawings. I think part of the reason why is because the fields that they associate largely incorrectly with engineers being involved with, like construction worker or auto mechanic or computer technicians, are fields that traditionally in the United States have been occupied by men. So they don't have a very accurate understanding of what they do. But even when they do, when you say, what is an engineer, they tend to think of that instinctively as more male. Now, I know there have been a number of studies that have been published using that instrument that we developed that do some intervention with children, and they find that after you've modeled things or shown and invited women to come in or girls to come in and do engineering, you'll see more images of girls start to pop up. But instinctively still science, math, and engineering, unfortunately in our society, are seen as being done by certain populations. And one of the reasons I got very interested in this is to try to think about how we can create experiences that help kids break down those ideas, in part by engaging in engineering themselves. So those little kids that are doing, designing walls or boats, it's going to be very hard to tell those kids that they can't think about being an engineer when they just did something called engineering in their classroom and enjoyed it. And so my feeling was, if you got to the children young enough before some of the societal stereotypes took firm hold, and then you showed them that they could engage in authentic challenges and create open-ended solutions, that it would be much harder to then have folks tell them that they weren't good at this or they shouldn't go into it. So trying to create innovative problem solvers is really the most interesting to me, but you do that through engaging them in action, not just telling them that they can do it. So that was a purposeful decision after we did some of that research.
Okay, thank you. I have seen a question. I think, I don't know, one of the participants are asking, can you please go back to the slide on the different materials and properties questions for problem solving?
I can get this.
I think they are taking notes.
We'll just... There we go. That one? Yeah, so in this one, what we try to do, and this is in part to provide a more level and equal experience for children, is we recognize in many settings, some kids come with knowledge and experience about different materials. So if you come from a household where you've never seen a pipe cleaner or a pom-pom, because that's not something your parents have bought or ever used, what we want to do is make sure that previous knowledge does not differentially allow some people to perform better. So we always have an experience before we have kids jump into the engineering that invites them to play with the materials, use them, discover how they work, and then think about which materials are best for the child. Working with little kids, like you'll notice that eraser on that sheet is a very boring pink eraser. We tried some really cute erasers that had smiley faces on it, and turns out doesn't matter if they didn't work. The kids loved the smiley faces erasers, and everybody wanted to use them even though they weren't good. So we carefully pick the materials and then try to get the kids to think about, if we're creating a hand pollinator and we're trying to pick up things, which of the properties matter? Does it matter if it's orange? Does it matter if it's smooth? Does it matter if it's fluffy? And get them making the connections between the properties of the materials and the kind of work it's doing, because that's fundamentally what engineers are always thinking about. And you know, as you make computers, you're always trying to make things faster, lighter, you know, last longer. And so getting the kids making those connections very early on and naming those properties is something that we think is a really important thing. And this can go down as young as, we've done this with kids, not these exact tables, but we've started to get the kids to think about naming properties as early as 3 and 4. They know instinctively, if you ask them to make a pillow, they know which materials are good for a pillow. They have experience with that. And so then you get them thinking about, well, why does this work well for a pillow? What does a pillow need to do in creating the outcome with the materials? You can start making those connections, you know, very, very early on.
Thank you very much. So this is for this slide, you are providing all these materials, and then students are defining what the properties of these materials. So do you have any suggestions, or since it might be through a distance learning now, in my opinion, so if this is not the in-class thing, but for the teachers or for educators or for parents, would you suggest them to maybe try out giving them the properties and asking kids to search at home, finding these things in their houses, I don't know, in their backyards?
Yeah, so I think you could do it a number of different ways. You could have them think about, so let's say we go back to the make a pillow. If you have very young kids and you say, let's make a pillow for our stuffed animal. Let's think about, what does the pillow need to do? What makes a good pillow? They all have experiences, and you can help them think about through those kinds of questions, and then think about, well, what kinds of things would we put into this? Let's say we have a bag, you get a little bag, you say, what kinds of things can we put inside this bag? And have them go, like you said, search for materials, bring them back. They can, you know, try them out. You could do more advanced kids. You could think about something like you need to create a waterproof backpack for maybe your cell phone. So that's a different set of principles. There's many more things that have to happen. So really defining a problem, then you have to define, what does it need to do? What are those criteria and constraints? It needs to keep the cell phone dry. It needs to fit on your back. It needs to be light enough you can carry. You know, you don't have to make a table of those. Those are things in a classroom setting. We would actually make a table and have the kids write those down and post it on the wall to remind them. But if you're doing something with your children, it becomes much more of a conversation. Okay, how will we know if we have made a good waterproof backpack? And then, you know, having the kids go think about which materials, and then test the materials out and think about which ones work well, because the one that might be most waterproof might also be really hot against your skin, because it doesn't let your skin breathe. And get them thinking about that and using, well, what else might you use, or how might you rearrange this material so some of it's more waterproof and some of it's less waterproof? How might you arrange it? Like, you'll notice oftentimes in backpacks, there's a little thing that goes over your zipper. That's to keep the rain from going through the zipper. So someone's engineered a little flap that pulls over your thing, and get them thinking about what are some other features that you might be able to do. And all that can be done through, you know, everyday materials. And then, you know, what's the next thing that you want to try to do? Like, is there a better way to create, you know, the kids can also come up with their own problems and solutions. Like I said, you might, you know, design a way to better organize your drawer, or remind yourself that you need to plug your cell phone in every night, or whatever it can be. You can sort of come up with, what are problems in our house? Maybe you have a window that's not, it just refuses to stay open. Like, what are some ways that we can solve that problem? And I think there's any number of things. Kids are pretty good at, if you can help them think about problems, at coming up with very creative solutions. I think the key is then not just jumping into tinkering. And there's a lot of tinkering and making, and that's all very good, but to move it to engineering, it sort of has to be more systematic in terms of tests, thinking about some of these properties, thinking about how you're going to gather data and evaluate it. And that can be informal. It doesn't have to be written down. But that to me is what takes it from just sort of random tinkering into things that start to develop a more systematic approach, which is what starts to bring it much more into the realm of engineering in my book.
So, Kristen, when I was visiting schools in the past, I heard some sentences like this from the kids. They say like, "Oh, engineering is not for me. Science is not my thing," you know. So they sometimes need a push, you know, or you know, a motivation. So, do you have any suggestions for parents? You know, how can they motivate them at home to do things like this?
Yeah. So I think part of the I don't like this is the way that they've previously experienced it. And so my suggestion would be don't necessarily, if they don't like science or engineering, don't start by saying we're gonna do science and engineering. Say, you know, we're gonna figure out a way to, you know, do X, fit more groceries in the back. Let's figure out how we're gonna create a system or something that interests the kids. If you have pets, a lot of times you can design things for pets. So you wanna figure out how, you know, Fluffy's water bowl, how we know when Fluffy's water bowl is empty. Can we design an alarm system that tells us when it's too light and it's not full of water? So I'd say start from interests of the kids and a problem that they will get engaged with and interested. And then at the end, you start to bring the connections back to what you did was engineering, what you did is science, because the labels don't matter that much, except if you, for my mind, you want them to understand sort of the role that these people play in our societies. And also if they're interested in it, eventually they may want to think about that as a possible career later on. But it's more for me about developing problem solvers who, you know, think about things systematically and use data and evidence. And it can be whatever problem the kids are most interested in. You can start there and then bring out some of these practices. These practices help make people better problem solvers, whether or not they plan to go into science and engineering. So I'd say for parents, start with what the kids are interested in, and then, you know, walk them slowly into the idea that this is science, or science and engineering are all around you. It's pretty much anything you do. I used to say to people, give me something you're interested in and I can come up with an engineering problem that it focuses on that, because engineering is just so all encompassing, from chemical to biological to materials to industrial. Like there's just so many different things that you can, and ways you can solve a problem. So I think it's really unique that way.
Yep.
I have two quick questions. I don't want to take a lot of time, but this is really interesting. I really enjoy talking with you today. So so there are a lot of kids who loves Legos, right? So Lego, you can make lots of engineering thing, buildings, you know, creation. But I always feel like buying a Lego set that is designed for making a certain type of robot, let's say, or a dragon, whatever, but there are like a certain rules you need to follow up from the booklet. I feel like this is like taking out the engineering or thinking process out of the kid's mind, because you are just following the directions. Maybe hands-on you can still do. But is it, do you think just giving them like pieces of Legos, just random, and then asking them to make a castle or something, instead of giving them a step-by-step solution just written there, is more useful in terms of triggering their creative modes? This is my first question. And the second one is, I will remember the second one.
Okay, so the first one, I think, yeah, so I think there's various reasons why you might do something with, like play with Legos. So for instance, you know, when kids are young, when my kids and my nieces and nephews are really young, when they first oftentimes get a kit that helps them build something they think is really cool. And part of that, I think, helps them develop a couple things. Like they learn to think and look at 3D images and translate them. So that's one of the things that, you know, we would practice. Can they look at the picture and then can they do it, which is valuable. Can they understand how things go together and start to spatially, you know, figure it out? The first time they do it, it doesn't always work. So I think there are some, and at the end of it, they get a product they think is super cool. So I think there's reasons to do that, but then I wouldn't stop there. So in my house, eventually we took all of the Lego kits and we sorted them by Lego type. So then they can make lots of spacecrafts and and my niece would make, fairy castles. So castles for her dolls and castles for her, things that her stuffed animals would use. And I think having that kind of creative play where the kids can go in their own direction is also, extremely useful. So I would not stop with the set procedure. There's reasons for doing that and skills that helps kids to develop. But I think having the creative outlet and having the kids use what they've learned or understand from the picture, oh, you can put these pieces together and they move in this way. They might learn the sort of little pieces they use from the descriptions, but then having the ability to go and create something that's totally different on their own forces them to internalize some of that thinking and, make mistakes and then back it up and then try it again, because not everything is laid out. So I think it's the more creative part that actually eventually you want to get kids to, if you want them to start thinking out of the box a little bit and learn that spatial design.
Can I also add something to this question? So those booklets for Legos can be used to students get familiar with the Legos and particles, I guess, because I spent a lot of time working with Legos.
Mm-hmm.
For example, I will show you something really quick. So see this holder, this cell phone holder.
Yeah.
So this is not written in any booklet or something like that.
Right.
So I have my kids and my students do such things. We can do something we can use at home.
Yeah.
So you give these materials, these particles to students, and then they can create something. So those booklets, I think you can use them, so they get familiar with the particles, how they can connect pieces, etc.
Yep.
So, but there is still creative thinking over there,
right.
I believe.
Yeah. So I think there's many good reasons to use Legos. They're easy, they're stackable, they're reusable. The one thing that you're not going to get so much of is that materials and their properties. So because the material is almost always the same, it's always plastic. They always behave in a fairly predictable way, which allows you to do certain kinds of things because you don't have to worry. So that's why I think a mix of various kinds of activities and various kinds of Legos will help kids develop some things, and they can get deeper because they're not worried about, if you stack 27 of these, will it still hold together? Somebody else has figured that out. But then having them also explore something with, different kinds of materials or coffee filters or, things around their house gets them thinking about, well, when might this work? And then really interesting is if you get them to mix media. So that's not often what you see kids do, but if you can use, Legos and then they run and get a pom-pom or a coffee filter to make whatever it is they want to do because of their, fairy garden, they want something else. I think that also can introduce more types of learning for the little kids that they don't only get from the Legos. So, but they're definitely a super easy, super reusable thing that really does encourage, creative play in kids.
I remember my second question.
Okay.
So it is just since I am in Silicon Valley and lots of my students are interested in software engineering, coding. So those are also the part of engineering, but we have seen mostly the hands-on engineering in your slides, in your talk. So what do you think about using this side in education for the kids? Because they love iPads, they love technology, they are into the computers all the time, they are designing animations. So this is like another part of side of engineering. Anything you wanna say on this?
Yeah, so I haven't done a whole lot in working with mobile devices. We're just starting that with my new project to think about how we can infuse computational thinking. So our approach right now is that the students start with something hands-on, and then we start to make it more and more abstract, and then put them in a place where they finally realize that you need a computer to help you solve the problem. Like the human mind cannot, those numbers are variable. So eventually we move them into spaces where they see the utility and start to think about what are the algorithms, what are the ways that you would solve the problem. So I think there's definitely a space for that. I won't claim by any stretch of the imagination to be an expert in that. I know there are many others in the United States who are more expert than us, but for us, I think our approach will be, which is, you know, not the only approach and certainly not the best approach, but it's just the way we'll do it, is to have an engineering challenge, like a hands-on one, and from that move the kids into the digital, because the concrete anchors what they're doing, and so the digital will help make whatever the physical is, you know, bigger, better, move it in different directions, and so have that sort of back and forth. But for instance, we in our work will not be teaching kids, you know, how to code. At the end of this, you will know how to code. They might be learning some basics of it or learning something about if-then loops, but our approach, because it's so anchored in engineering, won't be that. But which is not to say that I don't think kids should learn that. It's just that you have to sort of define what your focus is. But I do think that's very connected. And for me, the coding and the computational thinking has always been a tool. And when you can introduce it to kids as a tool to help you accomplish something they are highly motivated by, because most people are not, there's a few, but most people are not highly motivated. I just want to sit down and write code today. They want to do it for a purpose. And so I think making sure that that is highlighted with young kids as the endpoint, I think, is the important thing. And then, you know, they tend to pick up the skills with some scaffolding along the way to help them reach that goal. At least that's where I sit right now. But stay tuned. In another year or two, I'll know a lot more about that.
Thank you very much. Let me check.
Do you have any more questions?
No, I think I am okay. I really enjoyed listening and learning these things today. I'd like to thank Professor Cunningham for joining us today. It was very useful, and I think we are going to post this to YouTube channel, right, Dr. Marulju? So thank you very much for this beautiful information, beautiful webinar.
Thank you. My pleasure. Good. We'll all keep working on it, and hopefully we can give the kids in the next generation some more opportunities.
Be sure to join TechDev Academy's workshops and camps, and also read some great articles on their blog page.